Now we see the next indeterminate form, which is 1 raised to infinity. That is, if limit of f of x as x tends to a is 1 and limit of g of x as x tends to a is infinity, then we write the limit of the function of the form f of x raised to g of x in a slightly different manner. That is, the limit is equal to e raised to the limit of log of f of x whole upon 1 upon g of x as x tends to a. Okay, and the limit in the exponent gives us the 0 by 0 form. Right, now let us quickly go through how this particular expression is obtained. Okay, so for that, let us call the original limit as, say, L. That is, L equal to, we have to find the limit of f of x whole raised to g of x, right, as x tends to a. Now what do? Is we take the log of both sides. So therefore we have a log of L equal to, now we know that log of limit is equivalent to limit of the log. So therefore when we take the log of this particular quantity, the exponent g of x will come down as a multiplier, right? So therefore what we can write here is g of x into log of f of x. Correct. Now if we check, the originally limit of f of x tends to 1. So therefore if f of x is tending to 1, it means that log of f of x will tend to 0, isn't it? And g of x is given to be tending to infinity. So therefore basically here we have to evaluate the indeterminate form of 0 into infinity, and we know how to evaluate that. We have to take the g of x to the denominator of denominator. Alright, so therefore here we write this limit as limit of log of f of x, which tends to 0, therefore we keep it in the numerator. So log of f of x whole divided by, now g of x is taken to the denominator of denominator, so that is 1 upon g of x right, and the limit is taken as x tends to a. Now this becomes the 0 by 0 form, which we can evaluate using the L'Hopital's rule. And if you see, this particular quantity which we have obtained is the log of the original limit, correct? So therefore to get the actual value of the limit, we must raise this particular quantity as an exponent of e. So therefore finally we get the answer as shown here. Right? So let us solve one question based on this indeterminate form. Here we have to evaluate the limit of 1 plus x whole raised to 1 upon x as x tends to 0. Now we are very well aware of this result, which is, you know, a standard formula, and the answer is nothing but the number e. Alright, but let us see how that is obtained. Okay, so let's call this particular limit as, say, L. So L is written as limit of 1 plus x whole raised to 1 upon x as x tends to 0. Right. So as again, whenever we have the indeterminate form of any exponent, so we have to take the log. So that is equal to log of limit of 1 plus x raised to 1 upon x as x tends to 0. That is equal to, you can take a log inside, and is the limit x tends to 0 of log of 1 plus x raised to 1 upon x, right? Now therefore as per the rules of logarithm, the exponent 1 upon x will come down, so you will have 1 upon x into log of 1 plus x. Now if you see, okay, let us just write it in slightly different manner so that the required form is visible. I can write log of 1 plus x in the numerator divided by x in the denominator. Now if you put x equal to 0, you get log of 1 which is equal to 0. Okay, so the numerator tends to 0, and since denominator is already x which also tends to 0, we have got 0 by 0 form. So that qualifies for L'Hopital's rule, right? So therefore now the LHS, the left hand side is log L, and on the right hand side we use the L'Hopital's rule. For that we have to differentiate the numerator, and derivative of log of 1 plus x is 1 upon 1 plus x into derivative of 1 plus x which is just 1, and divided by derivative of x is also once again equal to 1. So therefore effectively we have to evaluate the limit as x tends to 0 of 1 upon 1 plus x. And now if we put x equal to 0, we get a finite number, that is we can easily see that it gives us 1 upon 1 plus 0 which is 1, and which is nothing but log of the required limit. So it is obvious that L is nothing but e raised to 1, so therefore the required limit is equal to e. So the answer of this particular question is E.